Here we go. So, to start with, binomial expansions. We're going to do a lot of review of it, and we're going to make it harder. But it's basically binomial expansions day 2 with a lot of just little added things to remind you what we've been doing this unit. So, for example, let's do one of these first. Would you tell me the first 3 terms of this? The first 3 terms of this. It's kind of like a binomial expansion in that, you know, there's a first term, then there's a second term, there's a third term, and they keep changing. That's why binomial expansions is thrown into this unit. All right, so if you put in a 1, Jake, what'd you get? 1/4 was the first term. Tobias, what'd you get when you put in a 2?
I got 8 over 4, 2.
All right, 2 to the third is 8. 8 over 4, I agree. And that is 2, okay? Are you getting bigger or smaller? They're getting bigger and bigger. Then that means, I got to throw in some terminology here. That means that they are diverging. It's getting further and further from each other. Okay? As opposed to the kind where if you had like 1 and it goes down to a half and then it goes down to a 4th and it goes down to a 1/8 and it goes down to a 16th. You get how it's getting closer and closer and closer to 0. It's like closing in on something. This is not. It's getting bigger and bigger. That's called diverge. I haven't been giving you all the terminology as we went along, so now I'm going back and doing that. This is called converge. You're getting closer and closer to something. All right, if you went 1 more and you put in a 3, it'd be 27 over 4, and that's getting even further apart. Okay, so the if you were to look at a graph, they're not like zooming in on something. All right, so imagine I graphed one where it started at 20, and then it went down to 10, and then it went down to 5, and then it went down to 2.5, and then it went down to, you see how it's getting closer and closer and closer to 0? It's like having an asymptote there. And it's just going to zoom in on that asymptote, and it just almost looks like it gets right on top of it eventually. All right, so that's called, what's this again? Converge. Can you add them all up if they converge? Yes, you can. It's like finding this area under this curve. If this gets closer and closer and closer to 0, it's effectively like it's going to end. It's effectively like it's going to touch that line. And so then that is a finite amount of area. Whereas diverging ones that go like this, can you add up all the things that are underneath that line? No, because it's just getting bigger and bigger and it's never going to end. Okay, so that's like 1, 2, 4, 8, 16, etc. Is that converging or diverging? Diverge. And can you add them all up? No. All right. What would the R value be here? Well, something bigger than 1, right? You're multiplying by something bigger than 1. When it does this, you're multiplying by something less than 1 because it's getting smaller each time. R is less than 1. Then you have converging. And you can add them all up. What's that formula that you would use? Don't look at the board. Use your brain. It starts with A0. What's that formula you'd use to add them all up if they converge? Over 1 minus R. How many of you knew that? You're probably counting on the fact that we're going to give them to you on the test. And we are. And that's kind of sad. Makes me sad. But I feel like that's part of a rigorous class is having to memorize a few formulas. But I guess we're going to give you a break on that. it is true in the real world. You can look up formulas. It's not hard. If you're in, let's say you're an engineer and you need a certain formula, you can just go Google it. Real world, they don't have to memorize formulas anymore. Okay, so let's do this for, like I said, it started with 12. And let's say that it cuts it down by 2/3. Its R is 2/3. Can you please tell me what the grand total would add up to then? And it's weird that it goes on forever and yet it adds up to a finite thing. Zodi, could you shut the door back here, please? So you should have said 12 over 1 minus 2/3, which is 12 over 1/3, which would be 12 times 3, which would be 36. Raise your hand if you had 36. Okay, cool. So the words converge is the new thing. Now, one more thing I want to show you that converges, and these are weird. There are functions that you'll learn like later in calculus that do this. They start off with big swings like this, and then they get smaller and 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 smaller. If you had to guess, do you feel like that is converging or diverging? Do you get how those are going to eventually get infinitely small, and then it's basically going to effectively stop? Would you agree converging? It is. That's like multiplying by a negative. Do you get if you multiply by a negative, it goes back and forth between positive and negative and positive and negative? Like if I multiplied by negative a half, so let's say we started with 6. And our R was 1/2. That would be easy. It'd just be 6, 3, 1.5, etc. But what if we had negative a half? I'd like you to just list the first few terms. It starts with 6, then you multiply by negative a half. All of a sudden it drops to negative 3. Negative a half again. Multiply by negative a half again. And on this quiz that you have today, you can use a calculator. So I'm fine if you want to bust out a regular calculator out of your backpack, or B, use the iPad's calculator to do a little multiplying. I don't really need you to go very far, but I need you to see that this gets closer and closer and closer to 0. It just does it from two different sides of the line. It goes wave. It's kind of like a sine wave, except it gets smaller, smaller, smaller. Is that converging or diverging? Converge. All right. So 6, half of that's 3, half of that's 1.5. We're multiplying by a negative, so it was negative 3 times negative 1/2. And then now if I times it by negative a half again, this is like half of 1.5 would half of $1.50 be 0.75, but it's negative. And it gets to be smaller and smaller numbers that just alternate back and forth between negative and positive. Converging means that it will add up. You can add this all up. That make sense? How about if I was multiplying by negative 2? Let's start with 20. Multiply by negative 2. What would be next? If R was negative 2, what's next? Say it.
Negative 40.
Good. What's next? Positive 80. What's next?
Negative 160.
Converging or diverging? Diverging. It's going further and further apart. Started with 20. Went down to negative 40. Went up to positive 80. Down to negative 160. It's getting further and further apart, and not like zooming in on something. It's getting further and further apart. If I want to give you a better picture, it'd be like That's diverging. That kind can't add up. R is bigger than 1. If R is bigger than 1, the number, the absolute value of the R actually, never actually said that before, but I think it's true. So if R equals -2, some people would say, well, that's less than 1. No. You're multiplying by a number that's going to make it bigger and bigger and bigger. So this is diverge. Can't add them up. Okay, enough about that. Now let's go back to what we were doing yesterday was binomial expansions. Let's do a nice simple one. X minus, I did throw in a negative, 2 to the, well, squared. You were doing that 3 years ago. But how about to the third? Write out all 3 terms. What's wrong with what I just said? There's 4 terms. Be careful with that negative. I'll pause for a second. Let me give this a shot. Okay, just to get you started. I like Pascal's triangle, and if it was an easy one, I might use Pascal's triangle. So this needs 4 terms. I can use 1, 3, 3, 1 to find the starting coefficients. Okay, but I got to do another number here because of this 2. That has to flow through, and that will multiply by these starting coefficients. So I'm going to put them in parentheses. You don't have to, but that's part of my answer. And then there's also the x part of the answer. So Zodi, what did you do next? I'm just curious.
I then filled out the x's going from x to the third, then x to the second, x to the first, and then x to the 0, which is just basically no x.
Good. Now let's do the -2. Miss Paul, can you do the -2?
Yeah, for the first one I did -2 to the 0, which is just 1. But and then the next one is -2 to the first, -2 to the second, and then -2 to the third.
All right. Now we have to clean it all up. Everybody do that. Fagan, tell me the first one. Minus 6x squared. Okay, good. Stop. And then we're going to go with Spargo next. Tell me the the third term. Yep. Positive 12x. And then can you tell me the last one? -8. Because this is just a 1 and this is just a 1, and then that's -2 to the third, which makes -8. And there's my answer. Make sense? Okay. What if I had asked you, what is the coefficient on the x squared term? Would you know what that means? Would everybody please highlight it? You've got an iPad, you know what the highlighter is. The coefficient on the x squared term. Did you just highlight that? Good. There's more terminology here. Highlight the constant in the same color. Highlight the constant. Did you know that's the constant? The thing that doesn't have a variable is constant. It'll stay -8. When I change x, it'll still be -8. Okay, that's constant. There's one more name for that. They call this the term independent I just spelled independent wrong, that's okay. Independent of x. The term independent of x. That's the same thing as the constant. You're going to see that terminology. Term independent of x. All right. how do these get more complicated? Well, basically, the numbers get more gross. So let's say I had a 2, but x is over 2, minus 3 to the power of 7. That would be cruel. So I'm not going to make it that hard. I'm going to say, we'd have to do 8 separate terms, right? Would you just find me the first 2 terms of this? There would have been 8, but I only went to the first 2 terms. Okay, well, how am I supposed to get could I make a Pascal's triangle with like 8 numbers? Yeah, but that's going to be a pain, isn't it? Who remembers what this first one would be? You know, instead of Pascal's triangle where it goes like 1, 3, 3, 1, you know, those kind of numbers. Who remembers how to do it with a C? Ah, you would have all failed that part of the quiz we're taking later today. Yes, it's a quiz. It's not counting the summative, but it does count in the formative. And here's how you do it. 7C0 is the first one. The next one will be 7C1. And I'll even coach you on how that works. Do you remember down the outside edge of the Pascal's triangle, it's always 1s? That one's 1. You know, because it's always like 1, 3, 3, 1. 1, 2, 1. It always starts and ends with a 1. All right, so then there's a 1. And 7C0 would have been, so you can know how to do 7C1, it would have been 7 factorial over 7 minus 0 factorial with an extra one of those. The last number in it gets repeated on the bottom. And 0 factorial is really equal to 1. So that's why this one came out to 1, because it's really just 7 factorial over 7 factorial. So it's 1. Tobias, can you tell me what 7C1 would be in terms of factorials?
7 factorial over 7 minus 1 factorial, which is 6.
7 minus 1 yeah, you're right. Sorry, is 6 factorial. Good. Times an extra one of these, 1 factorial. Very good. And what's that?
Just 7.
It's just 7. He's correct. Good. That's how you find the Pascal's triangle numbers for these, because you don't want to have to go out, because the ones we do in the test might be like 15. You can actually make a Pascal's triangle. It's got 15 numbers across, but it takes a long time. All right, then you got to do the x over 2 everywhere. X over 2 to the 7th. X over 2 to the 6th. And last but not least, you have to do the negative 3's. Negative 3 to the 0. Negative 3 to the 1. Well, it's not that bad. This one is just x to the 7th over 2 to the 7th. Notice I kind of like distributed out the power of 7. This term is a little more complicated. It's 7 times 3 is 21, and it's negative, so it's negative 21. X to the 6th over, remember, that's a 2 to the 6th. And if they asked you what the coefficient was, everything that's not the variable is the coefficient. So it would have been negative 21 over 2 to the 6th. 2 to the 6th is really big, I think. Is it 128? Did anybody check that out? Anybody verify 2 to the 6th? Is it 64? Thank you. So then it's negative 21 over 64. Oops. That would be the coefficient, and the constant, sorry, not the constant, and the rest of it would be the x to the 6th. Okay, I kind of helped with that one, so let's have you try one. Ready? 2 minus x over 3, and all of that to the 5th, and I only need the second term. There would have been 6 terms. All I need is the second term. Pause for a second while you give that one a try. When you're done, check with the kid next to you. Okay. So, I personally wouldn't have made a Pascal's triangle for this. You could. But to do that part, I would do 5c. I want the second term, then it's 5c1. I know it's a little confusing. This one, the first term is 5c0. All right, so 5c1, what's that really? It's 5 factorial over 5 minus 1 is 4 factorial, with an extra 1 factorial thrown in, and that doesn't really matter. So then it's 5 times 4 times 3 times 1 over 4, 3, 2, 1. All that cancels except for the 5. 5 is the only thing left. There we go. Then you go through and do your 2's. It's 2 to the 5th first, and then this one will be 2 to the 4th, which by the way is 16. And then I go do my negative x to the 3rds. This one would start with negative x over 3. Notice I put the negative only on top. If I put the negative on the top and the bottom, it would cancel out and it wouldn't be negative. And then that's to the 0 to start with. So for the term I care about, it would be negative x over 3 to the 1. So the 16 times 5, help me out, what is that? 80 times negative x over 3 to the 1, which is really just negative, I'm putting it in the front, x over 3. So if they asked me what degree that term had, I'd say it's degree 1. If they asked me what the coefficient was, I would say, oops, I was trying to highlight, I would say it was negative 80/3 is the coefficient. Raise your hand if you had that one right. That's most of you. Okay. Any questions about it? All right. So, let me give you one more relatively easy to the 15th, and it's easy? Yeah. If I tell you I only need the 3rd term, and you can leave answers with powers in them, like you might have 2 to the 5th times 3 to the 7th. Okay, I only want the 3rd term here. Pause for a second, let me give this a try. The 3rd term. Well, first I'd figure out the 1st term, and at least part of it. I'd go, okay, so instead of binomial, definitely not going to use the, not going to use Pascal's triangle. I'm going to use C. So this would have been 15C0. The 2nd term would have been 15C1. And then the 3rd term, the key one, would have been 15C2. Now, if you left that in your answer, I'd have to mark it wrong because that's a math problem. So 15C2 is good to know, but you have to calculate it out. You'd at minimum have to write 15 factorial. 15 minus 2 is 13 factorial with an extra 2 factorial. And then know what that means, which is really 15 times 14 times 13, etc. But it comes down to 15 times 14, and then the 13 on cancels. And I have all over 2, which can simplify because 14 over 2 is 7. So it's really just 7 times 15. So I can do that. 15 times 7. Did you get 245? Uh-oh. 7 times 5 is 35. 7 times 1 is 7, 8, 9, 10. Uh-oh. I did it wrong. Sorry. Trying to go fast. 105. How about that? Okay. So 105 was that key, what I call Pascal's numbers. And now I can use the easy part. X to the 15 would be first. X to the 14, X to the 13. And then I can do my -5 to the 0 here, -5 to the 1, and -5 squared, which is 25. The negative got canceled off. So then it's 25 times 105 times x to the 13. I'm just too lazy to multiply those two out, but there you go. And this part right here is called the coefficient. This was the x to the 13 term. Any questions? Okay, review. I want to know, is this converging or diverging? Better figure out the first couple terms and see if it's growing or shrinking. Converging or diverging? First term you do is stick in 1 and you get 1. Then you put in 2 and you get 1/4. Always do 3 terms because right now we don't know if they subtracted 3/4 or if they multiplied by 1/4 or if it's something different than that. So now I'm going to put in the third term. Make it 1/9. Oh crap. Was I multiplying by anything consistent there? No. All right. So you guys can only do converging ones where you've got an R value that's consistent. Do you get this one is getting closer and closer to 0? So is it converging? Yes. But can you actually add it up? No, because you need an R. To use this formula, you have a starting term, but you don't have an R that is consistent. You know, it has to be a common ratio, something you can multiply by everything single time. Okay, so that's convergence versus divergence. This is a reminder of how to find infinites, and I think that's along with all the other stuff we just talked about. I think that is enough so that you're ready to take your little Schoology quiz, which is a quiz/homework for tonight. So everybody open that up. I can't do the problems for you, but if you are stuck on a problem, I don't get what they mean by this, bring it up. Let me give you a hint, help you a little bit. That's all I have for the video for today.